out your MacBooks. That'll be good. Those people that I'm talking to. So with 1F, the thing to remember with 1F is while we're simplifying them, the first thing we do is we expand them. The second thing we do is we then choose to simplify them. So in a way, guys, it's an upside down triangle in terms of the process. You'll have a lot of working out on your next line, and then it'll slowly come into not much working out. And I'll show you what I mean by that. Let's take the first one, 20 over 2a. So 20 over 2a, before we start to simplify, a good way of going about it is to try and expand it first. Okay? And by that, we can do it in one of two ways. We can leave 20 up the top, and on the bottom, we can write 2. What's in between the 2 and the a? A times. We can expand it out like that. Okay, so we could do it that way. Expand it out like that. And then we can see that 20 and 2, both are even numbers. We could simplify them. So our next process could be to simplify them. How many 2's go into 20? 10. How many 2's go into 2? 1. Okay. That becomes 1 times a. We want to simplify that. It can become 10 over a. That's as simple as we can get because, of course, we don't write in the 1a. We don't write in that 1, do we? All right, I'll come to you in a minute. The other way we could do 20 over 2a is to say, well, 20 actually is a common factor of 2 10 times. Okay, so on the top line, if you're good with your times tables, you could do it like that. 2 times 10, 2 times a, they cancel each other out, and that leaves you with 10 over a. So I don't mind, I've said from the start of the year, there's 2 ways of doing, or multiple ways of solving in maths. I show you 2 ways, there might be other ways that you want to do it. Okay, but the main thing is to expand and then simplify. All right. Let's have a look at this one now, for example. B, C over B. Okay. So what's on our top line? We expand first. What's on our top line, Harry? Yeah, and how would you write that? Because we're trying to expand it.
B times C.
Excellent. With B times C, and that would be divided by
10.
Just B. We can't do anything with B, so we just leave it as B. So B times by C over B. Okay? Now, think to the good old days before we worked with letters. All right? If you had a fraction that looked like that, how could you simplify that? You could simplify it by 1, is what Georgie says. Why would you simplify it as being 1, Georgie? It's a whole number. There's 6 lots of 6. Okay? Or you can say, if we were to divide that by 6, we'd get 1. If we were to divide that by 6, we'd get 1. 1 over 1 equals 1. Okay? Do people remember just by a nod of heads? Do you remember doing this process? You would have done it in year 6. Been a long time ago now for you guys. All right, but that's the process you would have done. 81 over 81. It's 1 over 1. Therefore, it's 1 over 1. Therefore, it equals 1. All right? Another set of basics that we'd like to talk to you about is how could we simplify 81 over 1, Holstein? Don't know. That's all right. Beth? That's all right. Taylor? There we go. Jack? It's just 81. It's saying how many 1s go into 81? There's 81 of them. Okay. How could we simplify that? Monique?
1 goes into 9 times.
That's right. and so it's the whole number of 9. There are a couple of basics that we're picking up from your past, which will help us in this, okay? What's the rule? Anything over 1 is whatever's on the top line. Yeah, that's the rule, isn't it? Anything divided by 1 is whatever's on that top line. That's what we saw there. Back to this. Let's look at C now, okay? What would be on the top line? What would you write next, Beth? Cool. X times Y divided by X times Z. Okay. Thinking back to this process now. Thinking back to that. Is there anything that's similar on the top that's on the bottom? Holsty? X, what could we do with those X's? We could make them 1. X divided by X is 1 is 1. Okay? What's 1 times Y, Ash? 1Y, good. And the bottom line, 1 times Z, 1Z. That's right. Could we make it better, Sean? Could we make it better, Harry? Y over Z. Sorry, Harry. You just drop the 1 off, don't we? We've been speaking about that. We just drop the 1 away, and so we have 1 over Z. All right. Y over Z. Did I say 1 over Z? I don't know. Let's clear the screen a bit. It's getting a bit confusing. Is there another one up there that you would like me to go through? Just talk to me and tell me. Someone yell out. That's all right.
Still the same way it's squared.
Okay, so let's go through a squared one, shall we? Let's start with that, and then we'll work towards a more complicated one, which is Jack's request. Let's try D, shall we? That's the start of our squares. Okay. What would be on the top line there, Nikita? Yeah, we've got that. How could we expand it? Remember, we expand first. Sorry, I can't hear you, mate. Yep, no worries. Good work. A plus A or A times A. Okay, that's what we've got. A times A. We're expanding it first. Can't do anything with the bottom. It's just A. Okay. Thinking back to what I had up here before, is there something on the top that could cancel out the bottom, Luke?
Yeah, the 1.
Yep, and what do they become?
1.
Excellent. That becomes a 1. That becomes a 1. Now this question here is combining all our conversations back here before. 1 times A gives us what, Beth? 1A, and we don't do the 1 anymore, do we? We just go A over 1. Thinking back to what we had up down here, I think before, anything over 1, Holsty, is whatever's on the top line. So it's just A. That's right. This is better right. Okay. Shall we try F, or we're all right with F? Expand, then simplify. Tell me to go through F or just hold. Hearing nothing. Okay. Let's try G. This is starting to get a bit more complicated, isn't it? Let's look at G. What do we have on the top line in terms of expanding? Taylor, what do we have on the top line?
2 times x.
Good girl, 2 times x. What do we have on the bottom line, Taylor?
3 times x times y times y.
Excellent. 3 times x times y times y. Very, very good. We expanded it, you know, that triangle. There's more working out now than what we had before. Is there something we could simplify there? Are the numbers, could we simplify the numbers? The 2's going to 3 evenly? No, they don't. So we can't do anything with the numbers, but that should be our first thought. After that, what else could we simplify, Luke?
X.
The x's. Very good. So that becomes 1. That becomes 1. Okay. Is there anything else we could do there, Beth? Is there any y's up top? No, so we've got to leave them as they are. All right. So now we're in the process of simplifying. We've expanded, now we're going to simplify a bit. Harry, what's the top line? What's the top line say, first of all?
2 times 4.
2 times 1? Is that what the top line says? 2 times 1?
Oh, yeah, that.
Yep. So 2 times 1, which is, we know, 2. Okay. Ash, the bottom line, what's the first thing we should do? 3 times 1, which is 3. Are we finished with the bottom line? No, we haven't done the y's. Y multiplied by y, of course, Georgie, is y squared. That is now more simple than what this was. Okay? Only just process of elimination. We got rid of the x's. But that's about where it can finish. Okay? Those that are finding this a bit of a stretch, a bit of a start, then I would say go into 1F and start trying these more simple ones before you increase to more complexity or more, the trickier ones. Jack, and some of you others that are finding this really easy or no worries at all, I'm going to start to go through K. Okay? So pay attention if you want to, otherwise go on with your class learning. You be the judge of that. You own your learning. So let's have a look at K. Okay? What's the top line showing us? Jack?
24 A. Oh, no. 24 times A times B times C times C.
Good. Do you get my triangle analogy now? You got to expand it out and then you bring it back to more simple. What's our bottom line now, Holsey?
15 times A times A times C times C times C times C.
Good. Okay, so that's what we've got. The first thing we should look at, Garrett, is the numbers. Could we simplify those numbers?
No.
You don't think so? Who disagrees with that? I don't know who I'm talking to anymore. You could break it down, I reckon. You could. How could we break it down? Find the lowest common factor. So the lowest common factor that could go into 24 and 15, our 3 times tables could go into 24 and 15, couldn't it? How many 3s go into 24? 6 3s are 18.
9. 8. Oh, 8.
Oh yeah, cool, cool.
Well, you already said it.
8. How many 3s go into 15? 5. So we've simplified them. What else could we simplify there, Jack?
The A, mate.
The A and the A. The A on the top line becomes 1. The A on the bottom line becomes 1. Good. Anything else?
C.
The C on the top line can become 1. And the C on the bottom line can become 1. We then grab hold of our numbers. Okay? 8 times 1 times 1 gives us 8. And what are we left with? B times B, which is B squared. Over 5 times 1 times 1, 5. And what's the rest on our bottom line there, Georgie?
I think I can't really read it. I think it's A times C times C, which is A C.
Excellent. Sorry, my writing is so terrible. AC squared. Good. And you can see that we expanded it out. We did a lot more writing there, but then we brought it down to a more simple form. Okay? Expand, then simplify. Look for numbers, then do the letters. Okay? I'll leave it with you. Can I explain it better for anyone? No? Okay. Shuffle your cups if you need to. Remember, it's on YouTube to refer back to. And we'll work from there. Well done.